Welcome you all. Myself Dr. Sanjay Agarwal, Associate Professor in Electrical Engineering, School of Engineering and Technology. I am going to offer course which is available on the MOOC, that is Renewable Energy Technology and their uses. Dear learner, in this particular session we are going to discuss photovoltaic effect, and then we will discuss what is a solar cell and how you can calculate the efficiency of the solar cell. As you know, photovoltaic is the technology for conversion of solar radiation directly into electricity. A photovoltaic cell, also called a PV, that is photovoltaic, or a solar cell, is the device used for this purpose. And what is the purpose? Purpose is converted solar energy into electrical energy. Solar cells are generally made of high purity silicon wafer. Several materials such as silicon thin films like polycrystalline and amorphous, then gallium arsenide, cadmium telluride, copper indium diselenide, etc. are used to make solar cells. The PV technology has emerged as a promising technology to generate electricity for small application like lighting and meeting other electrical needs of household in unelectrified areas. Unelectrified area means where electricity is not available. Solar PV technology offers an excellent opportunity to provide electricity in a decentralized manner at locations where it is difficult to make grid power due to scattered population. This is because it is not economical to take grid connected power to such location. Moreover, solar radiation, the source of solar energy, is free, as you know, and it is also very clean and it is available in abundance. So now we have to understand what is a photovoltaic effect. The photovoltaic effect is defined as the process of generation of an electromotive force as a result of the absorption of solar radiation. The device used to convert sunlight to electricity by the use of photovoltaic effect are called solar cells or PV cells. The photoelectric effect was first observed in 1839 by a French physicist, that is Edmond Becquerel, who found that certain materials are capable of producing a small amount of electric current when exposed to light. In 1873, British scientist Smith observed that ability of selenium to conduct electricity increased in direct proportion to the amount of light falling on it. In 1880, Charles Fritz made the first selenium-based solar cell. In 1905, Albert Einstein described the nature of the light and the photoelectric effect on which photovoltaic technology is based. Albert Einstein won a Nobel Prize in physics for this. The first silicon-based photovoltaic module was built by Bell. It was too expensive to gain widespread use. In 1960s, the space industry began to make the first serious use of the PV technology to provide power aboard spacecraft. Through the space program, the technology advanced, its reliability was established, and the cost began to decline. During the energy crisis in the 1970s, the PV technology gained recognition as reliable and potential source of power for domestic and industrial applications. A typical solar cell has two layers of semiconductor material, generally silicon crystals. Since crystallized silicon is not a good conductor of electricity, so some impurities are added intentionally, and this process in which impurity is added is called doping. The bottom layer of PV cell is doped with boron, creating a positive charge. The top layer is doped with phosphorus, creating a negative charge. The surface between p-type and n-type semiconductor is called p-n junction. Sometimes it is also called a junction diode. The movement of electron from p-type layer to n-type layer results when sunlight gets absorbed at the p-n junction. You may understand photovoltaic effect by observing one by one. So first you can understand like this, that solar radiation, basically it is sunlight, are made of bundles of the light energy which is called photons or light quanta. Photons behave like particles having zero mass and travel with the speed of light. You know what is the speed of light? The speed of light is 3 into 10 to the power 8 meter per second. Each photon is associated with a particular wavelength of solar spectrum and has energy defined by that wavelength. Photons associated with different wavelengths have different energies, and you know that solar cell is made of semiconductor material. When the photons strikes on a solar cell, it may be either reflected, absorbed or passed through. Photons which get absorbed transfer their energy to the electrons in the semiconductor, enabling them to generate electricity. When enough photons are absorbed by a solar cell, electrons get detached from the material's atom and move to the surface. The energy of photon is transferred to an electron in an atom of the semiconductor device. With its newfound energy, the electron is able to escape from its normal position associated with a single atom in the semiconductor and is free to move and create to a current in an electrical circuit. When electron, that is negative charge, are able to leave their position, holes are created. Basically holes are positive charge. Now when large number of electrons travel towards the front surface of the cell, an imbalance of the charge between the cell's front and back surface create voltage potential similar to the negative and positive terminals of battery. Then electricity flows when two surfaces are connected through an electrical load. This electrical load may be any DC fan, any DC bulb. So these are the basically electrical load. So whenever the current has to be flown, that means you have to make a circuit. So two terminals of positive and negative are connected to the electrical load. Now you have to keep in your mind, if you are going to discuss about the photovoltaic cell, that photovoltaic cells are made of at least two layers of semiconductor material. One layer has positive charge while the other is negative charge. When light falls on the cell, some of the photons are absorbed by the semiconductor atom, freeing electrons to flow through an external circuit and back into positive layer. This flow of electrons produce electric current. Each absorbed photons can free only one electron, creating electron-hole pair. Now we will discuss what are the conditions for occurrence of photovoltaic effect. The basic condition for the photovoltaic effect to occur are: first condition is absorption of photons creating electron-hole pair in a semiconductor. Second condition is separation of the electrons and holes so that their recombination is inhibited. So third condition is collection of the electrons and holes separately by each of two current collecting electrodes so that current can be induced to flow in a circuit external to the semiconductor itself. There are many ways to achieve this condition. One common approach for separating the electrons from the holes is to use a single crystal semiconductor p-n junction as discussed. Here in this diagram you can see that photovoltaic cell is of two layer, as I already told you, that N-type semiconductor and P-type semiconductor. Then solar radiation is incident on the N-type semiconductor, and due to photovoltaic effect, current is starting to flow, and here you can see that one DC bulb is connected as a load. Now we will discuss solar cell and efficiency. There are three basic type of solar cells made from silicon, and these are single crystal solar cell, polycrystalline solar cell, amorphous solar cell. Here now we will discuss these single crystal solar cell, polycrystalline solar cell and amorphous solar cell one by one. So first is single crystal silicon solar cell. Single crystal cells are sliced into round or hexagonal wafers from its long cylinder. The process is highly energy intensive and also result in material waste, but gives the highest efficiency cell of order of 25%. The process is highly energy intensive and also result in material waste, but gives the highest efficiency cells of the order of 25%, which could be further enhanced to about 30% when used in combination with concentrator. Now we will discuss polycrystalline silicon solar cell in brief. The polycrystalline cells are made of molten silicon cast into ingots or drawn into sheets and thereafter sliced into squares. The efficiency of these cells is about 15%, but cost is relatively less as compared to single crystal solar cell. The third solar cell that we can discuss here, that is amorphous silicon solar cell. The silicon is spread onto a glass or metal surface in thin film. This results in making the module in one step. The production approach is least expensive, but the efficiency of these cells is about only 5%. Now here we will understand the conversion efficiency and how the power output of any solar cell can be calculated. In order to understand the concept of the efficiency of solar cell, you need to know a little bit of physics of semiconductor. When P-type and N-type semiconductor are brought in close contact, a p-n junction is formed. P-type and N-type semiconductor are relatively good conductor, but the junction where they are joined becomes non-conducting. This non-conducting layer is formed because electron in N-type and holes in P-type recombine and eliminate each other. A common solar cell is basically a large p-n junction. When sunlight falls on a semiconductor p-n junction, electrons within the crystal lattice may be freed, creating thereby an electron hole pair. These free carrier pairs are separated by a p-n junction and contribute to electric current. Only photons with a certain level of energy are able to free electrons in semiconductor material from their atomic bonds to produce an electric current. This level of energy, known as the band gap energy, is the amount of energy required to dislodge an electron from an atom and allow it to become part of an electrical circuit. However, photons with more energy than the band gap energy will expand that extra amount as heat when freeing electrons. A key to obtaining an efficient PV cell is to convert as much sunlight as possible into electricity. Crystalline silicon has band gap of energy of 1.1 electron volt. The band gap energy of other effective photovoltaic semiconductor range from 1 to 1.6 electron volt. Photons in this energy range can free electrons without creating too much extra heat. The photon energy varies according to the different wavelength of the light. The entire spectrum of sunlight from infrared to ultraviolet has photons of energy range from 0.5 electron volt to about 2.9 electron volt. Solar radiation are electromagnetic radiation which travel at the speed of light. The speed is related to the wavelength and frequency of radiation by this equation, which can be written as C is equal to lambda V, where C is equal to what? C is speed of light, as I already told you that speed of light is 3 into 10 to the power 8 meter per second, and lambda is a wavelength and nu is frequency. So according to quantum theory, an electromagnetic wave is made of discrete bundle of energy called photon energy, that is h nu. So you can write E is equal to h nu, where this E is energy of photon and h is Planck constant, which have value 6.6 into 10 to the power minus 34 joule second. It is interesting to see that while all photons travel at the speed of light, but there exists a distribution of energy among them. So on the basis of this particular formula, we will discuss one example. So here you have to determine the range of wavelength of solar radiation capable of generating electron hole pair in silicon, and energy gap of silicon is given as 1.12 electron volt. So just you have to note down that energy gap is given as 1.12 electron volt. So just you use the equation. So you can write lambda is equal to hc upon E, and as you know the value of h is equal to what? That is 6.6 into 10 to the power minus 34 joule per second, and you know this also that speed of light, which is equal to 3 into 10 to the power 8 meter per second. So now just you have to put the value in formula lambda is equal to hc upon E. So E is equal to what? That is a 1.12 electron volt. So it can be written as 1.12 into 1.602 into 10 to the power minus 19. So it comes in joule. So now just you have to put all this value, and after the solving you will get the value of lambda is equal to 1.11 into 10 to the power minus 6 meter, which can be written as 1.11 micrometer. So dear learner, in this particular session we have discussed what is a photovoltaic effect, and you know photovoltaic effect is basically if solar energy is converted into electrical energy, that is called photovoltaic effect. And in this particular session we have discussed how photovoltaic effect occurs. Then we have also discussed the efficiency, and on the basis of the given formula we have also calculated one example on this particular topic. I hope you must have understood the concept of the photovoltaic effect and efficiency of the solar cell. In the next section we will discuss how you can calculate the efficiency, then we will discuss how the power can be calculated, what are the different parameters on which electrical efficiency depends. Thank you very much.